Okay, if you're 7 Excel, we are working from the Advanced 2 textbook. And if you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 10.7, operations in scientific notation. Operations in scientific notation. And it can be found on pages 450 and 451. Okay. So let's start with adding and subtracting. Adding and subtracting. Adding and subtracting scientific notation. And we're going to divide this into 4. And I can make it bigger. There we go. Okay, so adding and subtracting scientific notation. So we have 4.6 times 10 to the third plus 8.72 times 10 to the third. So both of these numbers are written in scientific notation. Our first factor is between 1 and 10, and we have a power of 10. The first factor is between 1 and 10, and we have a power of 10. And we need to add these together. So since our power of 10 is the same, it's the same on both of these, it makes life a lot easier. We're always trying, when we're adding, we need to make sure that our power of 10 is the same when we're adding and subtracting. So since our power of 10 is the same, we have 4.6 plus 8.72 times 10 to the third. Now use a calculator for this. 4.6 plus 8.72 is 13.32 times 10 to the third. But we're not done because this is not scientific notation. 13 and 32 hundredths is greater than 10. So we need to turn this into scientific notation. Well, to do that, I'm going to convert this into 1.332 times 10. Since it's greater than 1, it's greater than 10, and I'm turning it into scientific notation, my exponent is positive. And then here's my 10 to the 3. 1.332. Here I've got 10 to the 1 times 10 to the 3. Since my base, we're going back to exponents, since the base is the same, my base is the same, I'm going to add my exponents, and I end up with 1.332 times 10 to the 4th. Okay, so when we're adding and subtracting scientific notation, we need our power of 10 to be the same. We need that power of 10 to be the same. So let's do another one. So we've got 7 and 8/10 times 10 to the negative 5 minus 4 and 5/10 times 10 to the negative 5. Okay, 7 and 8/10 times 10 to the negative 5 minus 4 and 5/10 times 10 to the negative 5. Let's look at our power of 10. Our power of 10 is the same. So this makes our life a lot easier. We have 7.8 minus 4.5 times 10 to the negative 5. So use a calculator for this. 7.8 minus 4.5 is 3.3 times 10 to the negative 5. Now, since this is already in scientific notation, 3.3 is greater than 1 and less than 10. It's between 1 and 10 times 10 to the, this is already in scientific notation. I'm done. So I'm done. Since it's already in scientific notation, I'm done. That's nice. But life doesn't stay that simple, because what happens when our power of 10 is not the same? We have 3.5 times 10 to the negative 2 minus 6.6 times 10 to the negative 3. Uh-oh. Our powers of 10 are not the same. So we need to rework one of these so that we end up with the same power of 10, so that they're either 10 to the negative 2, they're both 10 to the negative 2, or they're both 10 to the negative 3. So in my opinion, it's easier to break negative 3 up into negative 2. So that's what we're going to do. We're going to take this right here, and we're going to rework it. So I've got 6.6 times 10 to the negative 3. I'm going to break this negative 3 up into 6.6 times 10 to the negative 1 times 10 to the negative 2. My base is the same. I just took that negative 3 and I broke it up. Negative 1 plus negative 2 is negative 3. So I broke it up. Now I want to keep my negative 2. Since this is negative 2, I want to keep this negative 2. I want to get rid of this negative 1, and I can't just throw it out. So I'm going to rework it right here. So 6.6 times 10 to the negative 1 is 0.66. Negative 1 is telling us we move that decimal to the left, one place value. So this is equal to 0.66 times 10 to the negative 2. So I've reworked this. I've reworked this number in scientific notation so that I now have a power of 10. My power of 10 is to the negative 2. Okay, it matches here. So this is going to come straight down. So I've got 3.5 times 10 to the negative 2 minus 0.66 times 10 to the negative 2. Okay, now my powers of 10 are the same. So I've got 3.5 minus 0.66 times 10 to the negative 2. So 3.5 minus 0.66 is 2.84 times 10 to the negative. And since my first factor is already between 1 and 10, this is written in scientific notation. I'm done. Okay. But life doesn't stay that simple, because sometimes we end up with something like this. Okay, we have 8.2 times 10 squared plus 3.41 times 10 to the negative 1. So there's a couple of things I can do. I need to somehow break this down so that I have a negative 1 power of 10, or I need to somehow break this down so that I have a power of 10 to the second, to the 2 here. Now, there's really no easy way to do this one. We can like add and subtract and find a way to do it, but in my opinion, the easiest way to do this is to first break this down into the number. 3.41 times 10 to the negative 1 is 0.341. Now we need to work this number so that we have a 10 to the 2. So I want to move my decimal point to the left 2. So I now have 0.00341 times 10 to the positive 2. Because if I multiply this by the positive 2, it comes to the right. My decimal point comes to the right 2, and I end up with my original number. So in my opinion, when you have something like this where it's not easy to convert this exponent to a positive 2, turn it into its standard form, then rework the standard form so that you get a power of 2, the power that you need. Okay, so now I have matching powers. I now have 8.2 times 10 squared plus 0.00341 times 10 squared. Okay, I'm going to add. And my power of 10 is the same. So I've got 8.2, so I'm going to end up with 8.20341 times 10 squared. So sometimes it's easy to break the exponent down so that you end up with a factor that you need. Sometimes it's easy. You can break the exponent down and do this. Other times it's not as easy, so it's easier to turn that number into its standard form, then rework the standard form so that you have a power of 10 that you need. Okay? Okay, so now let's do multiplying and dividing. Okay, let's talk about multiplying and dividing scientific notation. Multiplying and dividing scientific notation. We have 1, 5, 2, 1, 2, 3, 4, 5. Oh, I've got 6 examples here. But I think these ones are all pretty easy. So let's do this. We'll break it up into 4. Okay. So here's our first problem. 3 times 10 to the negative 5 times 5 times 10 to the negative 2. So because this is all multiplication, we can kind of get rid of those parentheses. 3 times 10 to the negative 5 times 5 times 10 to the negative 2. And because of the commutative property, we can rearrange all of these. 3 times 5 times 10 to the negative 5 times 10 to the negative 2. Okay. Now, Now, 3 times 5, we can, the associative property says we can put our parentheses where we need them. So 3 times 5 is 15. And here, my base is the same. My base is the same. So I'm going to add these guys together. Negative 5 plus negative 2 is negative 7. But this is not in scientific notation because this is greater than 10. So I need to rework this so that it's in scientific notation. So I have 1.5 times 10. I moved my decimal to the left, so my exponent is positive. Since it's greater than 10, my factor is greater than 10, my exponent is positive. Everything else comes down. Now, once again, my base is the same, so I can add these guys together. 1 plus negative 7 is negative 6. So my answer needs to be in scientific notation as well. Okay, let's do another example. Oh. Okay. 6 times 8 times 10 to the negative 5. Okay, we don't, because it's multiplication, we don't really need those parentheses. Now, because of the associative property, I can regroup. So 6 times 8 is 48 times 10 to the negative 5. But this is not in scientific notation. 48 is greater than 10. So I need to rework this so that it's in scientific notation. So 48 is 4.8 times 10. Because this is greater than 10, my exponent's positive. Everything else comes down. Now, because my base is the same, I'm going to add these guys. And 1 plus negative 5 is negative 4. Okay. So let's do another one. Okay. We have 7 times 10 to the second power times 3 times 10 to the fifth power. So here again, because everything's multiplied, we can do away with those parentheses. The commutative property says we can rearrange these. And then the associative property says that we can regroup them. So 7 times 3 is 21 times 10. Since my base is the same, I'm going to add the exponents. 2 plus 5 is 7. But this is not in scientific notation. So I need to rework it. So 21 is 2.1. Since it's greater than 10, my power is positive. My exponent is positive. And now, since my base is the same, I'm going to add these guys together. Okay. So I've got 3 dividing examples. How about if I do that on a separate page? Okay. So here we go. I have 1.5 times 10 to the negative 8 over divided by 6 times 10 to the 7. I'm going to rework this so it's easier to see. 1.5 divided by 6 times 10 to the negative 8 divided by 10 to the 7. So I haven't changed anything. I just changed how it looked. I haven't changed the value. I've just changed how it looked. Okay, 1.5 divided by 6 is 0.25 times 10. So here I'm dividing my base is the same, but I'm dividing my exponents. So I'm going to subtract. So I've got 0.25 times 10 to the negative 15. But this is not in scientific notation. This is, my first factor is less than 1. So I need to rework this. So this is going to be 2.5 times 10. Since it's less than 1, my exponent is negative. Now my base is the same, 2.5. My base is the same, so I'm going to add these guys together. Negative 1 plus negative 15 is negative 16. So when we're dividing scientific notation, sometimes it's helpful to rewrite it so that it's easier to work with. Okay, let's take a look at another example. We have 9 2/10 times 10 to the 12th power divided by 4.6. So here again, I'm going to rewrite this so that it's easier to work with. 9.2 times 10 to the 12th divided by 4.6. So here, I can even rewrite this again to make it a little bit easier to work with. 9.2 divided by 4.6 times 10 to the 12th. Okay, so 9.2 divided by 4.6 is 2 times 10 to the 12th. And since that's already in scientific notation, we're done. Okay, let's take a look at one more example. Okay, 1.5 times 10 to the negative 3 divided by 7.5 times 10 to the second power. So I'm going to rewrite this. Divided by. And I'm going to rewrite it yet again, just so that it's easier to work with. 1.5 divided by 7.5 times 10 to the negative 3 over 10 to the 2. 1.5 divided by 7.5 is 0.2. It's 2/10. Because my base is the same, and this is a division problem, I'm going to subtract my exponents. 0.2 times 10 to the negative 5. But this is not in scientific notation because my first factor is less than 1. So I need to rework this. So it's going to be 2 times 10. Since my factor is less than 1, my exponent is negative. Now, my base is the same, and I'm going to add my exponents. Negative 1 and negative 5 is negative 6. Okay, so that's today's lesson. We are adding, subtracting, multiplying, and dividing scientific notation. These are the examples. You may need to refer back to the book or watch this video a couple of times. You might also want to look at the video examples that are on the agenda. They're helpful as well. So that's what we're doing today.